All right, welcome to The Explainer. Today, we're diving deep into something that's, well, it's absolutely fundamental to database performance, but it's also something a ton of developers get wrong. I'm talking about indexing. This is the one tool that can literally make your app fly or grind it to a halt.
So let's just jump right in with a question that might sound a little crazy. Are your indexes actually helping you, or are they secretly hurting you? I mean, could that thing you've put in place specifically for speed be the very bottleneck that's bogging your system down?
And that right there, that's what we're going to call the indexing illusion. It's this super common misconception, and trust me, even seasoned developers fall into this trap. It's the belief that, hey, if a query is slow, just slap another index on it, right? Problem solved. But not so fast.
Because here's the deal, the core trade-off you always have to think about. On one side, yeah, indexes are amazing. They make your read queries, your select statements, incredibly fast. But there's a flip side. Every single time you write data, we're talking inserts, updates, deletes, the database has to do extra work. It has to go and update every single index on that table. It's like having multiple address books for the same person. Every time they move, you have to update all of them.
So if there's this cost, why do we even bother? Well, it all comes down to one thing, the need for speed. When you go from a tiny little table to one with millions or even billions of rows, the difference isn't just small. It's the difference between your app working and not working at all. It's moving from a crawl to an absolute sprint. So let's picture this. Without an index, if you ask the database to find something, it has to do what's called a full table scan. This is literally like I handed you a 1,000-page novel and told you to find every mention of the name Bob. You'd have no choice but to read every single word on every single page. It's an ON operation, which is just a fancy way of saying it gets slower and slower the bigger the table gets. It just doesn't scale. But a well-placed index completely changes the game. It's like flipping to the back of that novel and finding a perfectly organized index. You look up Bob, it tells you he's on pages 15, 237, and 812. Boom. You go right there. You've just turned that painful ON scan into an incredibly efficient O log N lookup. It's a night and day difference.
Okay, so we've established that indexes can be absolute lifesavers for performance. But, and this is a big but, not all indexes are created equal. It's not about just having an index. It's about choosing the right tool for the specific job you're trying to do.
Let's take a quick peek into the toolbox. You've got your simple, straightforward, single index on one column. Then you've got the more complex composite index, which covers multiple columns. And you even have something called a covering index, which is so efficient it can answer your query without even looking at the actual table data. But you know, the one that trips people up the most, it's that composite index.
Yeah, so these composite indexes are amazing when you're filtering on, say, a customer ID and an order date. But here's the crucial detail, the part that I'll admit tripped me up when I was starting out. The order of the columns you define in that index, it is everything. It literally dictates which queries can use it and which ones can't.
And real quick, let's peek under the hood at the different structures. The most common one you'll see is the B-tree index. Think of it as the versatile Swiss Army knife of indexes. It's great for general-purpose lookups, range queries, finding everything greater than or less than something. Then you have the hash index. This one's not a Swiss Army knife, it's a scalpel. It is ridiculously fast for exact match lookups, but ask it to do a range query, nope, can't do it. Totally different tools for different tasks.
All right, now let's get to the really juicy stuff. This is the core of the illusion. We're going to expose the 3 most common indexing traps that I see developers fall into all the time. These are the mistakes that turn your performance-boosting tool into a performance killer.
Okay, trap number 1. This one is probably the easiest and most common one to fall for. It's simply having too many indexes. You know the feeling. A query is slow, so you add an index. Another one is slow, you add another index. Before you know it, you've got this huge pile of them, and you think you're helping, but you're actually doing the opposite.
Because, and I can't stress this enough, every single index on a table slows down your inserts, your updates, and your deletes. There's a real cost, a right penalty, for every index you maintain. So please burn this into your brain. When it comes to indexes, more is not always better.
All right, trap number 2. This one's a little more subtle, but it's just as bad. Remember how we talked about those composite indexes? Well, this trap is all about getting the column order wrong.
The best way to think about this is a classic phone book. It's indexed by last name, then first name. So finding Smith John is super fast. But what if you wanted to find everyone whose first name is John? The index is totally useless for that. You'd have to read the entire book. It's the exact same principle for your database. If you have an index on last name, first name, and your query only looks for first name, the database just can't use that index efficiently. It's a waste.
And that brings us to our third and final trap, ignoring cardinality. Now, cardinality sounds like a big, scary academic word, but don't worry, it's actually a really simple idea. It's just a measure of how many unique values are in a column.
And here's why it matters so much. An index is most effective when it can quickly narrow down the results. So on a high cardinality column, like a user ID, where pretty much every value is unique, an index is amazing. But what about a low cardinality column, like a status field, that can only be active or inactive? An index there is kind of pointless. It doesn't help the database narrow things down much at all. It's just extra overhead for almost no benefit.
Okay, so we've seen the traps. So the big question is, how do we avoid them? How do we see through this indexing illusion and actually make our queries better? Well, the secret is to stop guessing and start measuring. You need to use the tools that let you peek behind the curtain and see what your database is actually thinking.
And your single most powerful tool for this is a little command called explain analyze. It exists in pretty much every modern database. When you run this on a query, it doesn't just give you the results, it gives you the database's entire game plan. It shows you step by step how it's going to get the data, and most importantly, it tells you if and how it's using your indexes. So, let's bring it all together with a few best practices for smart indexing. First, use explain. Don't guess, know what your query is doing. Second, monitor your system for slow queries so you know where to focus your attention. Third, be surgical. Only index the columns you're actually using in your where, join, or order by clauses. And finally, be a good database gardener. Go in there and prune the indexes you're not using anymore. It'll make your writes faster, guaranteed. Look, once you really understand that core trade-off between read speed and write cost, you can make sure your indexes are working for you, not against you. They stop being a hidden liability and become the powerful tool they're meant to be. Which of course leaves us with one final thought. What other illusions are hiding in your database?